Okay, this is IT Track. My name is Boyd. I am in Bangkok, Thailand. It has been very hot here the past few days, so I'm incredibly happy that I am in an air-conditioned office. And today we're going to talk about GLBP, Gateway Load Balancing Protocol. If you can look at our topology in front of you here, we're going to set up 3 routers to do load balancing with GLBP group 22. Now, before we jump right in and get at it, which I want to do because that's where the fun happens, first let's talk about FHRP, First Hop Redundancy Protocol, which is a topic on the 300-115 CCNP SWITCH exam. We also remember this topic from our CCNA studies, although in the SWITCH exam it goes into it in quite a bit more detail. So why do we care about FHRP? I mean, besides the fact that it's a test question, what can it do for us? Well, it's actually a pretty cool technology. And to explain kind of how it works generally, if we take a look at this topology I have on the left, and let's say that we only have R2. We don't have these other 2 routers yet. So we don't have these links to R1 and R3. This is our gateway out, right? All our hosts down here at Switch 1, if they want to get anywhere outside of their local area network, they have to go to their default gateway, which in this case is R2, with the 192.168.1.12 gateway address, and they use that to get pretty much everywhere. Ultimately, they can get through the ASA and access the internet, but the problem can occur if this interface or this interface go down, or this router has a problem and just explodes. What happens to our hosts? What happens to our clients? They're stuck. They can't get anywhere. They can't get out. So that's where FHRP can help us. We can add another router or 2 or 3 or more, and it can add some redundancy. So if this guy goes down, maybe this guy will pick up the slack. This router can have a huge problem, and they're still going to be able to get to their Twitter and their Facebook and all the other incredibly important things they have to do on the internet. So that's what it'll do for us, and we actually have 3 options by which we can implement FHRP. First one that we'll talk about real quick is HSRP, Hot Standby Router Protocol. And this is pretty widely implemented because you can do it on routers and layer 3 switches, but the lower end layer 3 switches like 3560s. Now GLBP, which we're going to do in our lab, you cannot implement GLBP on a low end switch like that. It's got to be a 4500 or one of the big boys. So HSRP, Cisco proprietary. It communicates on the 224.0.0.2 address, which, if you can remember, is the all routers multicast address. So that's where, when he sends his hello packets, they're all listening on this address so they can receive these hellos and process them and figure out what all the other routers are doing in terms of HSRP. We have an active router and a standby router. The active router, if we implemented it here, I'll put it on R2, he'd be the working gateway. And maybe R1 we could set up as the standby, and if R2 went down, R1 would take over his responsibility of being the gateway. We also can have other routers participating in the group, but they are not an active nor a standby. They would be in a listen mode. So if I had 3 routers here, R2 was the active, R1 was the standby, R3 would be in a listen state. And if R2 went down, this guy would become active, and this guy would be the standby. And you can have up to 255 groups per interface. Now with HSRP, the virtual MAC address, and we'll talk more about virtual MACs when we get into the GLBP topology. The virtual MAC address for HSRP follows this format. And like I mentioned in the beginning, you can implement this with routers or layer 3 switches as long as it's a Cisco switch. The hello and dead timers, or the hello and timeout interval, are 3 and 10 seconds respectively, and each router configured with HSRP has a default priority of 100. So priority just refers to who's going to be the active router. If you have one router that's got a priority of the default of 100, you make another one a priority of 110, the guy that's 110 is going to be the active router. Higher is better when it comes to priority. Okay, so then we have VRRP, or Virtual Router Redundancy Protocol. It really acts similarly to HSRP, except it's not Cisco proprietary. It's the industry standard. So you can do this on other devices besides Cisco routers and switches. It also operates on a different multicast address, 224.0.0.18. I'll get back to this default preempt in a sec. It's the same in terms of how many groups you can have per interface. The hello and dead timers are different. The default is 1 and 3 seconds, and actually, I think this is a better default to have. I think 3 and 10 seconds is kind of long. Priority is the same as HSRP, the default is 100. This, of course, is different. It's the virtual MAC address format. They also have a different term for what router is the active router. Here, they call it the master router, not the active router. And the rest of the routers are in standby state. And again, you can implement it with routers and layer 3 switches. Now, this default preempt, this is the only one of the 3 protocols that has this option where preemption is enabled. Preemption says if a router comes online and he has a higher priority than the current active router or the current master router in terms of VRRP, the router with the higher priority is going to take over the role of the master router. So for HSRP, if you're configuring it, it won't do it by default. You have to configure the preempt. If I can type, or if I can write with this silly marker. You have to configure the preempt command to enable that. And we're not going to do those today. We're going to do GLBP because it's way better. So let's talk about GLBP and start working on our topology. I actually have 3 routers sitting next to me and a switch and an ASA and a bunch of hosts. We're going to configure R2 as the AVG. And what is an AVG? Well, it stands for Active Virtual Gateway. He is going to be the big cheese router in charge of our GLBP group. Now, if R2 should fail, we're going to have R1 set up so he will take over the AVG role. We're also going to configure R1, R2, and R3 here as AVFs. And AVFs are Active Virtual Forwarders. And this is really the cool thing about GLBP. They can all provide gateway services simultaneously, unlike HSRP and VRRP, which cannot. So we're going to do that. We're going to configure R2 with the load balancing weight, which will be twice that of R1 and R3. He's going to handle twice as many ARP requests because, well, that's just the way I want to do it. And this is really subjective, right? I mean, depending on your network, it doesn't have to be twice as much. It could be 1.5, it can be whatever. It just depends on your link speeds, how your network is set up, and all that kind of stuff. But we're also going to configure interface tracking. And what that's going to help us do is if, for instance, this goes down, we might still want him to handle some of the requests because he can go through these links here to get the host out through the gateway, but we don't want him to do twice as much because he's lost his main link out. We're going to configure interface tracking so we can have it decrement the weight, and we'll explain more about that when we do the config. They're already configured with IP addresses, by the way, and the network is all set up, and for those of you interested, I'm running EIGRP here between everything. So they all have their own IPs, but what we're going to do is we're going to assign a virtual IP, which will be our gateway address. It's basically going to be shared amongst all these routers. So they're going to all have a virtual IP of 192.168.1.1, and they are all going to be assigned their own unique MAC address. So we can take a look now and kind of look at the specifics of GLBP, how it compares to HSRP and VRRP. Again, it's Cisco proprietary, so you got to use Cisco devices. The multicast address is a little different. It's the 102. We have 3 ways that we can do load balancing. We can do a round robin method where it just kind of goes from router to router to router and allocates ARP requests based on who comes in when. Or we can do weighted, which is what we're going to do. You can also do a host dependent. And we can have up to 1024 groups. You can have as many as 4 virtual forwarders per group, basically active at the same time. You can have 4 routers providing gateway services simultaneously. In our scenario, we have 3, but you can have up to 4. The hello and dead timers are 3 and 10 seconds like HSRP. And again, I think this is long. And it's just amazing how things have changed. I can remember starting out, and I was working for this company back in the late 90s, mid-late 90s, and we first started getting people on the internet, right? I mean, I was upgrading machines from Windows 3.1 to Windows 95 at this time. And people would call me and say, hey, my internet's down. And I'd be like, well, okay, just kind of deal with it, right? But now, man, it's like people get down for like 2 seconds and they're screaming bloody murder. So 3 and 10 seconds is kind of long. We're actually going to configure the hello and dead intervals in milliseconds when we do this. We're not going to even do seconds. The MAC address format, the virtual MAC, is different. This format they will all use. And like I said, you can use routers and switches, but they have to be higher end layer 3 switches. You can't do it on a 3560. Okay, so now let's get to the fun part and actually start typing in a bunch of commands and seeing this stuff work. First, we'll check out our IP address settings and we'll look at what interfaces are assigned to what IPs. So show IP interface brief, our favorite command of all time on Cisco routers. So we have Fast Ethernet 01, and he's the interface we're going to be working with. FA00 is the one that's going out to the ASA, and the serial 0/0/0 is going to R2. The tunnel is not really doing anything right now, so we can ignore that. So we'll go into interface mode, and the first thing we can do is just set up our virtual IP, GLBP 22. And 22 is just an arbitrary number that I picked because I happen to like it. But yeah, you can pick any number from 0 to 1023. IP 192.168.1.1. Now, I mentioned I don't really like the timers that it has by default, so we're going to set our own timers. GLBP 22 timers, and we can actually do it in milliseconds. So that's what I'm going to do. I'm going to do half a second for the hello and 1.5 seconds for the dead. And we're going to keep his default priority of 100, so we don't have to put a command in there for the priority. But we do have to enable preemption. And we also want to use the weighted load balancing option. So we'll put that in, and now we're going to specify exactly what this particular weight will be, along with an upper and a lower threshold. So what this is saying is we have a starting weight of 100, and we're going to do interface tracking. If one of the interfaces go down, we're going to set it to decrement the weight by 5. If the second interface goes down, it will decrement by another 5. Therefore, it will be lower than our minimum threshold value of 91. It'll be 90 if they both go down. And this router will stop functioning as an active virtual forwarder. So we also have to set up interfaces to be tracked. So we'll do that, but first, I'll set up the GLBP reference to those interface tracks. And I'll create 2 tracks, one will be 22, one will be 23. So now we'll configure the actual tracks, and that's easy enough. We just get into configuration mode, we get out of interface mode, and we'll do track 22, interface, and we'll specify Fast Ethernet 00. We're going to use the line protocol option. This means it's going to track whether or not the interface is up or down. Now we'll also create one more, and we'll do track 23, interface serial 0/0/0, line protocol. Now that ends our GLBP configuration on R1, so let's see what we have. So we'll take a look at the output from the show GLBP command. It shows our group number. It says the state is active. He's the AVG right now because he's the only one in the group. So he has the active role. Here's his virtual IP. Here are the timers we set. We have preemption enabled. The standby is unknown because there is no other router set up to be in this GLBP group yet. We have our weighting configured, our tracking configured, and we have one forwarder, and he's active. And this is the virtual MAC address that he assigned himself. Let's configure R2, but before we do that, I want to go over real quick how he's determining this MAC address. So how exactly does this router derive his virtual MAC? All these MAC addresses, every MAC address is represented in hex. The first 24 bits up to here are set. It's going to be this format all the time. And that's kind of how you know that he's using GLBP. If you see a MAC address like this, you know that GLBP is operating. So after the first 24 bits, we have 16 bits, which is labeled as xx.xx. So he gets numbers to throw in there from our GLBP group number. So we have a GLBP group number of 22. And if you remember from binary, 2 to the 16th is what? 65,536. Okay, yeah, and I know that my writing looks like a 6-year-old did it. Actually, probably like a 3-year-old is writing this. But I'll try to write the best I can with this Wacom tablet marker pen thing. Okay, so it's 2 to the 16th, which is 65,536, right? We have 16 bits here. Well, we don't have 65,536 possible groups. Well, what happens is you have 16 bits, but the first 6 bits are always going to be 0. 1, 2, 3, 4, 5, 6 zeros. Unchangeable. We have 2 to the 10th, or 1024 possible variations on the group number. So if we take 22 and we put it into hex, this is what we get. These two are kind of the continuation of this. So those are all zeros. Now our next two values, we have a 1, right? And what's this? 6. So 1/6. And the YY is basically the router number. Since this is the first router, he's going to assign himself a 1. So it's 0, 1. And we'll see when R2 comes up, he's going to assign himself as number 2, the second router in the group, and he'll be a 2. And R3 will be a 3. If we go back real quick to R1, we can see his address. Here's the 1601, right? This is the group number, and this is the router number. So that's how he gets the MAC addresses. It's actually pretty easy when you look at it in binary. And I'm a big fan of binary, by the way. Okay, cool. So we have that. Now let's configure R2. So here's R2, and let's take a look first at the IP addresses that we have. Fast Ethernet 00, similar to R1, is going to the ASA. Fast Ethernet 01 is the interface that we're going to put GLBP on. And then we have serial 000 and serial 030 going to R1 and R3 respectively. So on all the interfaces except F01, we're going to configure interface tracking. So let's get into interface F01, and most of these commands are going to be the same as we did for R1. GLBP 22 IP, and we'll put our virtual IP address in. We'll use the same timers. Now, we will put a different priority than the default for R2. We want to make sure that he is the active virtual gateway. And what we can do, as we see this happen, we can go to R1 and do a debug so we can see R2 taking over the role. And debug GLBP events. We'll make it 110. Now we'll go back to R1. Okay, so as of right now, R1 is replying with the different MAC addresses of himself and R2. Now, why hasn't R2 taken over the role yet? Well, because I forgot to put in the preempt command. GLBP 22 preempt. So now R1 should have a fit because he's losing his role as the active virtual gateway. In fact, you can see him going through these different states. He says, okay, I received a hello from a higher priority router. I'll become the standby. And now, how does ARP work? Well, everybody receives it, right? It's a broadcast. So R1 receives this ARP request, but he's not going to reply to it because he's not the active router. He's going to let R2 handle it now. So R2 is going to get all these ARP requests, and then he's going to respond with a different MAC address based on the waiting scheme that we set up. So let's go back to R2 and finish this config. So we'll do GLBP 22, waiting, and we're going to make him 200. So in effect, if he gets 3 ARP requests, he'll respond to 2, and he'll send the MAC address of R1 for the third one. It'll be a 2-to-1 ratio. And we're going to set a lower threshold of 101 and an upper of 110. And we also want to make sure that we put in the load balancing method of weighted. And we're also going to configure our interface tracking. Track 22, decrement. Now this, I'm going to set track 22 up for fast Ethernet 00. So if he goes down, I want it to decrement quite a bit. The serial interfaces, I will do decrement 10. So what we're saying here is if the fast Ethernet interface goes down, decrement by 80. Make his weight lower, more equal to that of R1 and R3. And if another interface goes down, if one of the serial interfaces go down, decrement it even more. If the third interface goes down, we don't want him to be an AVF, so his weighting value will be 100, which is below our minimum threshold of 101, so he will stop being an AVF until we fix it and bring those interfaces back up. So our configuration of GLBP is finished, but we have to set up the tracking commands in configuration mode. So track 22 interface F00 line protocol. And track 23 interface serial 0/0/0 line protocol. And track 24, interface 0/3/0. So that should be it for R2. Now we'll do a show GLBP. So what do we have? He is now the active virtual gateway. He took over the role which we saw. And there's the virtual IP, the timers, preemption is enabled. We have all our tracking configurations set up. An AVF on R1 and an AVF on R2. And now we'll set up R3. I am not going to configure tracking of interfaces on this one because I think it's kind of overkill. But we do want him to be a part of our GLBP group, so we'll do the basic configuration for R3. So we'll just do config T, and this interface happens to be F0/0. So we'll do GLBP 22 IP 192.168.1.1, GLBP 22 timers 500 and 1500. GLBP 22 will give him a lower priority. And we'll give him the same weight as R1. And we'll make sure he's load balancing using the weighted method. So now, if we do show GLBP, we see that he's in the listen mode because he's not the active, he's not the standby. But if one of those two should go down, he will change his role. He would actually become the standby. So we have our virtual IP, we have our hold timer, and our hello timer we have priorities of the active R2, the standby, which is R1, and the local router, which is 95. We have all the group members listed. And again, he's listening for all the addresses that are not his, and he's active for his particular virtual MAC, which follows that same format that we talked before about at 1603. So let's go to R2. And now we can see he's added and he's listening for R3's MAC address as well. So now what we can do is we can screw around with it a little bit and take some of these interfaces offline, shut them down, and see how these roles can change and the weighting can change based on the tracking conditions that we set. Okay, so what we can do first is shut down router 2 and emulate that he had some kind of horrible problem like a power out or something like that, and we'll see R1 take over the role as the AVG. And we'll make sure debug GLBP events is on. Alright, so he's not replying to anything because he's not the active router. We can see that. So let's reload R2. And we'll save the config to make sure that we don't have to reinvent the wheel. And when that happens, R1 goes into a frenzy because he knows that he has to become the active virtual gateway. And we see all sorts of messages coming up here. And basically he goes through the GLBP logic to take over the role as the AVG. And in fact, if the router shut down like we did, he actually sends out a message. R2 sends out a message saying, hey, I resign. Somebody else can become the AVG. And R1 receives that, and he says, okay, well, I'm the next one in line, so I'll be the active virtual gateway. And we can see right away he starts processing the ARP requests because R2 went away. Now, when R2 comes up, we'll give him a few seconds, he'll come up. He'll take the role back over because we set the preempt condition. So R2 will come back up with a higher priority, and he will take over the role again. But until that happens, R1's going to be able to process all the ARP requests, which is good. And we can see this with our show GLBP command, and it says, hey, the state is active. He is no longer in a standby state. And if we go to R3, we'll see that he is in a standby state. So if we do show GLBP here, he moved from the listen state to the standby state because there's only 2 routers up right now. So one of them has to be the active, one of them has to be the standby. And as we can see too, R3 has taken over the forwarding state for the down router. We know that that MAC address is still out there in the ARP caches of some of the clients, and R3 has taken it upon himself to process those requests. So he has 2 active forwarders. He's doing forwarding for R2 and for himself. Let's see. Okay, so while we're looking at R3, R2 came up and retook his role as the AVG again. So let's get into him. And there he is, state is active, reclaimed his title. So let's do one more thing. We'll pull down one of the interfaces on R2 to see how the weight will change. So if we go to F00, and we just do a shutdown command, and we look at the GLBP configuration now, or the status, we'll see that his weight has decreased. It's decremented by 80, because that's what we told him to do. We said, look, if that interface is down, if the line protocol is down, decrement your weight by 80, because we don't want you processing all those requests now. So he's down to 120. And if the other 2 interfaces went down, he would cease AVF altogether. So that's pretty cool. And FHRP is a pretty cool thing to use, and it's a pretty fun thing to configure too. So let's do one other thing just for fun. We're going to shut R1 and R3 down. So he's going to reload, the other one's going to reload. R2 is going to be the only one left. He's got to pick up the slack for everything. So it says there are 3 forwarders, 3 active, and he's doing all the work because the other 2 guys are down. Now, these will change once they come back up, but this is the great thing about GLBP. you're not putting all your gateway eggs in the same basket unless everything goes down except your one last router. But basically, you can have multiple failures and you're still going to have gateway accessibility. And that's really what we want. So I hope you got something out of this video. This was a lot of fun for me to do. We will see you next time.